plus 2. So for 2 equivalents of zinc, you react 2 equivalents of lead for every 1 mole of your lead. And then, since it asked us for the grams of the lead here, we need to do one more step, the molar mass for our lead. So for every 1 mole of lead, heavy load, we're at 107, 207, 0.2 grams. Bless you. And you should be getting 14.3 or something really close to 14.3, like 14.27.
Can you be number 24?
Mm-hmm. All of them? Okay. Okay. So we're told that we have 2.255 equivalents of aluminum, and we're wanting to know how many equivalents of oxygen will it react with. So equivalence to equivalence is just 1 to 1. Okay, so that one's straight. So 2.255 equivalents of aluminum will react with exactly 2.255 equivalents of oxygen. Bless you. It would react with 2.255 equivalents of anything. That could be iron, oxygen, lead, whatever. They're always in 1 to 1 proportions. Now when you talk about moles of oxygen, then what you want to do is you want to take the amount of equivalents it'll react with, and we want to get to moles. So your conversion factor for equivalents to moles is the absolute value of the charge. Since they started out using O2 here, that's what we need to use. So your equivalents from O2 equivalents to mole is going to be 4 equivalents for every 1 mole.
Is that because of the charge and then how many there are?
Yep. If they had said just O and not O2, you could use 2 here, but this is a case in which you're going to have to use 4 equivalents because they're specifically talking about diatomic oxygen. Okay, so that would be this first part. And then I'm just going to add on to this piece right here for this next one. If you wanted to go to grams of oxygen, you just got one more step. Right? We just got to use our molar mass. So for that part, you need to use your molar mass again for your diatomic oxygen. So for every 1 mole of O2, 31.9988 grams. And that would get you this second one here. Okay. So the first part, these first 2 conversion factors would be just for the moles. And then for the grams would be all 3. Okay. Now if we move to a different element here, regardless that it's a different element, it'll still react in the same equivalent proportions. So if you're reacting with, aluminum's reacting with hydrogen now, it's still going to react with 2.255 equivalents. So that many equivalents will react with hydrogen.
So you're just replacing it, like instead of doing grams, you're doing molecules.
Mm-hmm.
Or is it? Okay.
Yep. You're using equivalents now as your ultimate conversion factor. You can do it without balanced chemical equations. You can do it when you don't know the metal. You can do it when you don't know the molar mass. Awesome. So, but what's now the absolute value of the charge for hydrogen? Again, another diatomic. 2, right? So for every 2 equivalences of hydrogen, for every 1 mole of hydrogen, so this first part wanted molecules. So for moles, we're going to use what? What are we going to use to get out of moles and into molecules? Avogadro's number. I kind of run out of space here, so I'm going to write on an angle. Okay, so that's going to get us all the way from equivalents to molecules. And it's not going to matter what element we use. So chlorine will be the same thing, 2.255 equivalents. Then it'll be your molar mass for your chlorine. So, I'm sorry, your absolute value of your charge for your chlorine. Again, chlorine diatomic. So what's the absolute value of your charge? -2, and then absolute value is just 2. So 2 equivalents of your chlorine for every 1 mole, and then go straight from moles to molecules.
This is just like review, isn't it? Is that what he's trying to do?
This is review of everything. The wonderful thing about equivalence is it's going to force you to review everything all the way back to the beginning of the semester. Oxidation numbers, compounds, everything. And I would be prepared for all these questions. But if you can do it the molar mass way, and if you can do it the equivalence way, there's no question that a teacher can ask you in what you can't do. Because you can do it one way or the other, and it doesn't matter which way. It's whichever way you're more comfortable with. If you're more comfortable with doing the molar mass way, you can do every single problem we've done the whole semester the molar mass way. And now you can do every single problem equivalence way too, right? I'm going to skip that sulfur one because I kind of wrote over it, but it would be the equivalence for the sulfur here would be the same for the equivalence of the oxygen. It's just going to be 1 to 1. So the equivalence for your sulfur will be 2.255 equivalent sulfur. For your grams of phosphorus, you're going to start off with the same equivalence. And we would just go all the way into mass. But your equivalence for phosphorus is going to be 3. Right? So the charge for phosphorus is going to be -3. Absolute value will be 3. And then your molar mass for your phosphorus, 30.97376. Okay. Now, these are really the 2 most important ones, because this is really something that you more likely be asked on the test. These are good review questions, and you may have something like that, a little quick question like that on the test, but this really tests a lot of different things. So if we say, how many grams of iron now? So what's the charge on that iron? Someone said it. 2. He had to tell you the charge because iron can have 2 different charges. It can have the 2 or the 3. And it matters because you're going to get a different answer of reaction for each one. Now, molar mass isn't going to change, but only your equivalence is going to change for that. 5.847. So the only difference between that and the iron 3 is you have the same equivalence. You'd have a different equivalent weight here. It'd be 3 equivalents per mole, but the same molar mass. So the only difference for this iron 3 is you're going to start off with the same equivalents, but your equivalent charge for iron 3 is 3 equivalents per mole. So this will be 3 and 1, and then your molar mass will be the same. So that's how you get a different equivalent weight for iron. So the setup for it would be like this. The only thing that's going to change for that is this equivalent weight here. But see, like, then for something like uranium, you'll have 6 equivalent weights for uranium, right? because you'll have 6 possible charges for uranium. But then for something like all the group 1 elements, they're only going to have 1 equivalent weight. She'd ask me how to sing. What else? Other questions about equivalence? Anything else? No? Okay. Kind of everyone's starting to filter in, so I'm going to show you something. So you gotta love the state and e-learn people when they do maintenance on the servers and don't tell you. So I had it scheduled to post your all's, this right here, this study session, it was scheduled to post on Friday, but if you all tried to use it on Friday, Saturday, or Sunday, it said, sorry, we're currently done for maintenance. So it's up right now, it's posted. The link's down here at the bottom. For everyone who wants the extra SI session, the 3-hour block over the Thanksgiving weekend. I put a couple of days up there. So if you click the link, you can put your name in here. Where you see these ripples right here, hit that right there, and it's gonna open it up, and you can vote for multiple days there. Okay, so I put 4 days in there. I left Thursday off because love you all. Don't want to see you on Thanksgiving. I want to eat some turkey and go into food coma. So I put Wednesday up here because we don't have class tomorrow, so I have no problem. You know, if you all are already scheduled to be off work or whatever, we can meet tomorrow. The classroom will be open. We can meet Friday, Saturday, or Sunday. Someone's already voted, so put your name in there. If you can vote by tomorrow at 4:30, you can really do it by the end of class. That'd be awesome. The sooner we know the most popular time, the sooner I'm going to post it on there again and say, hey, the most popular time is. Or if you want to click back on the link, you can see what the most popular time is on there. So definitely recommend you do that. The first hour and a half is going to be review for exam 5. I have some of the older exams that questions tend to come up again on, and then we'll be reviewing the other hour and a half for the final. So that's a good time for you to come in and get good questions answered. Oh, I told everyone that was in the SI, this may have come up in your labs, but this is something definitely you need to be ready for the final. All the teachers love these 4 elements, and they will use them at least 10 times on the final, and multiple questions are in the same question over and over again. You need to know the charge of these 4 D group elements. They are consistent, they will always be the same. So aluminum will always be a +3 charge no matter what compound it's in, how it's arranged. Zinc will always be a +2, silver will always be a +1, and cadmium will always be a +1. There's an easy way you can do it on the periodic table, and you can find it. Look at element 13, aluminum. The 3 tells you what the charge count starts with. So aluminum starts at 3, and then it counts down into the periodic table. So 3, count down to zinc 2, count down to silver 1, and then count over to cadmium 1. Okay, 3, 2, 1, 1. Okay, but you do need to know these 4. They will come up on the final. All the teachers love them. I think when I'm